Now let's add, remove, and update our sets. We have a set of names, Sandy, Alice, and Dave, and let's have our first add. So we write names, which is our set, dot the method add, and let's have a name Sally added to our set. Let's here print our adjusted set. So between quotations here, add Sally, and let's have our comma out of the quotations and have our variable or set names. Okay, let's have this as a copy and a paste several times in order to apply other methods. Let's have another method here, update, and let's update using numbers between square brackets 5, 6, and let's print here update five and 6 and print names again. Let's have our remove here, just to remove any item, say 5 because it is added now in the previous step, and let's here write remove 5. You can select any other item. Let's here have our pop, and of course pop has an empty bracket. We expect it to pop out the first element. Let's have here update, and now let's apply a string, say Manel, and it is not recommended to use update with strings here. Let's see what will happen. Just remember it is a Manel here, and let's finally clear our set and see what happens. It should delete all items from the set and have here our empty brackets. Let's here have clear. Let's have our first run here. Add Sally. Sally is added anywhere in the set because it is unordered. Update 5 and 6. The update still anywhere in the set as long as it is not ordered. 5 here is removed from this set. Pop, it popped the first element. Manel, see how it is added here? Every letter separately and randomly. Of course, it is not recommended. If you just need to add a string, then use add. Clear set gives the set empty. Let's now have some operations on sets. So we'll delete all this and have our operations. Now we have 3 sets. The first one, 1, 2, 3, 4, 5. The second set, 3, 4, 5, 6, 7. And please notice that 3, 4, 5 are 3 repeated integers. They are common between set 1 and set 2. Set 3, 2 integers 6 and 7, which are common also in set 2 only. Now let's have our first operation, the union operation. So let's write, we have a new set called union set, which is equal to set 1 union set 2. So simply write set 1 dot union between brackets set 2. And let's have our print here. Simply print between quotations union, have our comma, and print the variable union set, which is our new created set. Let's have a run here to see what happens. Yes, union is 1, 2, 3, 4, 5, 6, 7. What really happened here is that all elements in both sets were added together and repeated elements were not repeated. They only appear once. This is our union. We can even have another syntax here. So let's copy this and have it pasted here. And let's have the new set union set simply equals to set1 union using this symbol set2. Let's delete those brackets here. Let's have spaces here to be more readable and print union set2 and let's see what happens. Yes, it gives the same result. So we either have dot method union or the union symbol here. You can even delete this print and abbreviate our syntax. Have here a print bracket just set1 union set2 and have our closing bracket here. And to be more readable, let's have here between quotations our union and let's close the quotation and have a comma here. Let's rerun. Yes, we have the same results. Okay, let's repeat this. Instead of a union, let's have an intersection. Let's have here intersection and let's have the method intersection. Let's have it printed here between quotations and let's have here intersection set. Let's have here the intersection set1 and instead of this sign we have the symbol and, which means intersection. Let's see what happens. The intersection gives the common elements between the two sets, which are 3, 4, 5 and 3, 4, 5 for sets 1 and 2. Let's have those repeated and instead of intersection, let's have our difference, subtracting two sets from each other. So let's write here difference, set 1 difference, set 2, which means set 1 minus set 2. Let's have here this repeated between quotations and let's have here our difference set printed. Difference set 1 minus set 2. Let's see what happens here. It gives the elements present in set 1 and not present in set 2. And therefore, if we have set 1 subtracted from set 2, which means set 2 minus set 1, it will give elements present in set 2 and not present in set 1. So we have here set 2, difference set 1, and here set 2, difference set 1. And of course we have here our minus sign. Let's have our print here. Yes, it gives 6 and 7, which are the elements present in set 2 and not present in set 1. Let's try another operation, which is symmetric difference. Symmetrics underscore difference. Now let's have this repeated here between our quotations. Here, and let's have the sign of symmetric difference, which is our hat here. Let's see what happens. Yes, it gives all elements none repeated in set 1 and none repeated in set 2. So it gives 6 and 7 because they do not exist in set 1, and it gives 1 and 2 because they do not exist in set 2. This is our symmetric difference. Let's now try comparison and testing. Let's have a quick look on superset, subset, and disjoint. Let's have an example here. Set 3 is subset 2. So we write here set 3 dot is subset and have our brackets here set 2. And to have a print here, let's print, have our bracket here, and at the end have our closing bracket, just to test whether set 3 is a subset of set 2. Set 3 contains 6, 7. Yes, it is a subset of set 2, and we expect a true here. Yes, we have a true. For a better output, let's have simply here between quotation is subset. And let's close the quotation and have our usual comma here. Now you can test something new. Is superset. So we have is super set. Let's test. Of course, 6 and 7 can never be a superset of 3, 4, 5, 6. So let's have set 2 here is a superset of set 3, and we expect here a true. Yes, a true here. But if we have set 1 is a superset of set 3, then we expect a false, because set 1 doesn't contain 6 and 7, so it can never be a superset. Here is our false. Now we can simply test something else, which is disjoint, which gives true if no common elements exist between the two sets. So let's have here is disjoint. And of course, let's have it repeated here. This is our method. So set 1 and set 3 have no elements common, and therefore disjoint gives a true. But if we try set 1 and set 2, we expect a false, because there are common elements between the two sets. Yes, here we are. Now let's study the membership of sets. Now let's have a new set here created called mySet, and it contains an integer, a string, another string, and an integer. So let's test the membership in. So let's have our if condition here. If choose any element, say hi, between quotations because it is a string. The membership in, and let's have my set here. Print between quotations hi exists. Otherwise, use our else here. So we have our shift tab and our else. Print between quotations here no hi, which means hi doesn't exist. And let's have our run here. Yes, hi exists. If we apply Sally here, Sally doesn't exist in my list. It gives no hi, it goes to the else. We can have another syntax here. We can simply print between quotations hi in my set, and it gives a boolean. If hi exists in my set, it simply gives true. This concludes with our sets. It is a type of collection surrounded by the curled brackets, not ordered, and therefore if we add or update new added and removed elements go anywhere in the set, We studied set operations and comparisons.